So for this section, we're going to discuss hyperbolic functions. It's going to be a fairly short section. It's important to see these functions. They show up a lot in engineering and physics and even chemistry, but we're not going to spend a huge amount of time on them this semester, but it is important to see them. So let's go ahead and start with our definition. So basically, we're just taking these exponential functions, e to the x and e to the minus x, averaging over those, so dividing them by 2, and calling this a hyperbolic cosine function. And so we're going to spend some time in the lecture seeing some of the properties of this function and kind of why we would want to call it a hyperbolic cosine function. Because this function, the hyperbolic sine, they behave in some ways, they share some properties with the sine and cosine function. So let's go ahead and look at what this function looks like. So we see here the two different pieces of the hyperbolic cosine function, the e to the x over 2 and e to the minus x over 2. And now we can see what we're doing is we're adding these two functions together to get hyperbolic cosine. So what's going to happen here is these are both at 1/2 when it's at 0. So if we add those, we're going to be up here at 1. But you can see as we go towards the positive x-axis here, the pink function, the e to the minus x over 2, gets really small. So when we add it to the purple function, we're not really changing the purple function much at all. And so we see this with the hyperbolic cosine function here, as we go through 1 when x is equal to 0, but then we approach those other two functions, the pink function and the purple function, as x goes to infinity and x goes to minus infinity. And we'll see one of the reasons this is an interesting function in engineering and physics is if you take, like, say, a telephone line or something like this, a power cable, and you suspend it between two different poles, it basically, when the shape it takes when it falls down and hangs down between the two poles, is a hyperbolic cosine function. And notice we can see from this looks like an even function. It looks like we basically can graph it to the right of the y-axis and then just flip it over the y-axis to get to the rest of the graph. Then we can go ahead and check that this is an even function directly. So if we plug in negative x for x, we see we get e to the minus x plus e to the minus minus x all over 2. And then we can see, just by simplifying this and rearranging it, this is exactly the hyperbolic cosine function. So this is an even function. And we can define the hyperbolic sine function similarly. So instead of adding these two exponentials, we subtract them now. So hyperbolic sine is just e to the x minus e to the minus x over 2. And we can see the graphs here. So the purple graph, again, is e to the x over 2. And now the pink graph is minus e to the minus x over 2. So notice when we take the negative of that, it flips over the x-axis. And now we're adding these two functions together, so it should go in the middle between these two functions. And so it looks something like this. So you can see again, in this case, it goes through 0 at x equals 0. And then as x goes to infinity, it approaches e to the x over 2. And as it goes to negative infinity, it approaches negative e to the negative x over 2. And from this, it looks like this is an odd function. So we can go ahead and check that as well. So we plug in negative x, and again, we just go through the algebra here. We get e to the negative x minus e to the minus minus x. And so if we simplify that, we get e to the negative x minus e to the x over 2. We factor out a negative from that, and we get negative hyperbolic sine of x. So in the actual lecture, we'll develop more properties of these functions and see a couple of examples of how they can be used.